Actually, medieval craftsmen were not somehow superior to us, but they knew wood far better than we do. They took seriously the things we today hardly care about. That is where the difference is. For example, they did not just cut down a tree at random. They were meticulous, carefully examining it. They looked at the bark, the angle of the branches, and how the crown sat on top. They would literally walk around the tree like a doctor examining a patient. If they saw a crooked tree, they understood that the grain inside might also be twisted. And that is very bad news for a roof beam. Something you put in there to stay straight can end up turning on you from the inside later. They also tapped the trunk and listened to the sound. You lightly knock on it with your hand. If it makes a clear, solid sound, fine. If it sounds dull, then you know there is something going on there. It might be rot, it might be hollow, it might be a problem that is not visible from the outside but gives itself away through sound. My grandfather did the same thing when choosing watermelons. Same logic, just a slightly different scale. Then where the tree grew was also very important. Trees growing on north-facing slopes were especially valuable. Why? Because they grew more slowly. Since they got less sun, the rings were tighter. If a fast-growing tree had, say, 8 rings per inch, a tree grown on a north-facing slope could have up to 40 rings per inch. That directly meant denser, stronger wood. They avoided trees struck by lightning. They also avoided trees with burn marks, because they knew those could create internal cracks. A beam that looks perfect from the outside can suddenly crack when load is applied years later. In other words, they were not looking only at the tree's present condition. They were also predicting what it would do in the future. Some of the beams they selected are still carrying roofs 800 years later. Think about that. 800 years. Meanwhile, our lumber yard just gives you dimensions and price. A 2x4, take it and go. Nobody selects trees one by one anymore. Nobody reads wood anymore. But choosing the right tree was only the beginning. There was also when to cut it down. And that is where the strangest but most interesting part begins. You have probably heard that trees were cut according to the moon's phases. At first, that sounds like nonsense, like somebody saying it after their third beer. But that is not how it is. German forestry researchers actually tested it. Trees cut during the waning moon, meaning between the full moon and the new moon, contained 4 to 5% less moisture than trees cut at other times. It may seem like a small difference, but for timber that will dry for years, that is a pretty serious advantage. Why does this happen? The moon's pull affects water movement in plants. It is the same force that drives ocean tides. At certain phases, sap is drawn down toward the roots. If you cut the tree then, you are starting with drier wood. Medieval guild records did not treat this like a nice if you can manage it rule. They gave exact cutting dates. If you broke the rule, you could be expelled from the guild. Your career could literally end because of the moon phase. Harsh, yes, but they were serious. Winter cutting was another advantage. During that period, trees were already in dormant mode, so they had pulled most of the moisture from their outer wood into their roots. So a tree cut in winter during the waning moon was starting at the driest possible point. They were not satisfied with one advantage. They stacked advantage on top of advantage. Modern commercial forestry does not work like that. Cut it, ship it, do not waste a minute. 24/7, 365 days a year. The result? The lumber starts causing problems before it even reaches the site. Warping, cracking, decay. The trouble starts before it is even installed. We traded the free calendar in the sky for kiln-dried headaches. But moon timing was only the beginning. The real thing was what they did with freshly cut green wood. Green wood, meaning wood straight from the tree, still full of sap. Most people today would call that unusable. Too wet, let it sit, throw it away. Medieval carpenters, though, called it exactly what they wanted. Because green wood actually worked. It was easy to carve, cutting like butter. You could shape joints much faster with hand tools. Try doing that with kiln-dried oak, and you will burn through 3 chisels before lunch. But the real trick came after assembly. Everyone knows wood shrinks as it dries, but what they understood was the direction. Wood shrinks about twice as much around its growth rings as it does along its length. They used that as a tool. They would cut a mortise and tenon joint slightly oversized. Then they would drive in an oak wedge. Years would pass. What would happen? The wood would compress. The fibers would lock together. The joint would actually get stronger over time. It was like the building was slowly giving itself a permanent hug. I have seen joints from the 1300s that are still almost impossible to take apart. Not because anyone glued them, but because the wood spent centuries squeezing itself tighter. Of course, this required serious calculations. You had to know very well how much shrinkage would happen. If you calculated wrong, gaps would appear. If you calculated correctly, nature would do the clamping for you forever. Why do we use kiln-dried lumber? Because it is predictable, uniform, and fast. But kiln drying is basically like cooking wood at high heat. The cells do not get time to settle or relax. Internal stress builds up. Then cracks start. Those cracks are called checks. And checks become open doors for water and insects. The medieval green wood method prevented most of this from the start. But their work was truly about patience. Properly drying oak takes about 1 year per inch of thickness. Think about that. A 12-inch beam sits somewhere for more than 10 years just waiting. And they really did it. The trees used in the roof of a church in Nottingham were cut 50 to 80 years before they were put in place. Cathedral projects stockpiled timber knowing their grandchildren would be the ones to use it. We start watching a series and quit halfway through. They were stocking the future. But the point is this: when wood dries very slowly, the cells are able to adjust gradually. Internal stress does not build up. No surprise cracks appear years later. Compared to kiln drying, the difference is huge. Modern kilns get wood ready in days instead of years. Efficient, yes, but in effect you are cooking the cellular structure. Think of it like the difference between slow-cooked meat and meat heated in a microwave. Technically, both are cooked, but one is beautiful and the other is not. The stacking method also mattered. They placed the lumber on raised platforms with spacers between the boards. They arranged it so air could pass evenly through the pile. No random stacking. This was engineering. Even if they did not call it that, they were calculating airflow. And the difference in strength was real. Air-dried oak can be 20 to 30% stronger than kiln-dried oak of the same species and grade. Same tree, same wood, but completely different performance. Because the cell walls are not heat damaged, they remain strong. We gave up patience and chose speed, and then wondered why structures became weaker. But slow drying was only one part of their game plan. They also knew something modern people mostly ignore about wood species. And that explains why some medieval structures survived for centuries while others quickly rotted away. Oak was used where weight had to be carried. Posts, beams, anything taking serious compression loads. And there was a bonus. Oak contains tannic acid naturally. Insects hate it. Fungi cannot get a foothold. One wood, two problems solved. Elm was used where wood would be in contact with water. Its grain is so tightly interlocked that it is very hard to split. Water wheels, ship keels, well linings. Anywhere wood faced water for decades, elm was the answer. Anyone who has tried splitting elm firewood understands exactly why it was chosen. Then there is chestnut. And this one still makes me laugh. They use chestnut for roof framing because spiders avoid it. The tannins repel insects, which means no webs collecting in those beautiful vaulted cathedral ceilings. Medieval builders were solving a cleaning problem through material choice. That is thinking ahead. Ash was used for almost every tool handle and weapon shaft in Europe. Why? Because its long fibers absorb shock and distribute impact before breaking. When a Viking swung an axe and hit a shield, an ash handle kept the hands from going numb. The same reason baseball bats were made of ash for a long time. And it was perfect for bows too. Not because it was flexible, but because heartwood and sapwood behave completely differently. The heartwood compresses on the belly of the bow, and the sapwood stretches on the back. One piece of wood doing two opposite jobs at the same time. English archers won battles because, centuries earlier, someone had noticed how wood behaves. Now look at modern construction. We use the fastest-growing pine from commercial plantations. Soft, weak, identical wood going into decks, framing, furniture, fences. The same species used for completely different jobs. Makes sense, right? Actually, no. It makes profit. But here is something even more interesting. Medieval preservation methods were basically chemistry before anyone called it chemistry. This is where medieval craftsmen start looking like mad scientists. They figured out chemistry centuries before chemistry was a thing. And honestly, some of their methods sound completely insane until you realize they really work. Take water preservation, for example. Sounds backwards, right? Using water to protect wood from water damage. But medieval craftsmen would soak their timbers in running streams for months. Not still water, running water. The constant flow leached out all the sugars and starches that fungi and insects actually eat. What remained was pure cellulose, basically indigestible wood fiber that nothing wanted to consume. Then there is bog oak. Pull a log out of an Irish peat bog after 5,000 years, and it is still workable. The combination of no oxygen and tannic acid essentially pickled the wood like a cucumber. I have held a piece of this stuff. Black as coal, hard as iron, and older than the pyramids. My personal favorite, medieval shipwrights deliberately set their planks on fire. They charred the surface until it carbonized. That blackened layer became a barrier insects could not digest and water could not penetrate. Fighting fire with fire, literally. And the beam ends. They knew end grain absorbs moisture 200 times faster than side grain. So they rubbed linseed oil into every exposed end. A simple solution with huge results. Now here is where it gets weird. Some builders buried their timbers in the manure heaps. Yes, manure. The ammonia from decomposition penetrated deep into the wood and acted as a powerful fungicide. It smelled terrible. It worked beautifully. Modern pressure-treated lumber uses chromated copper arsenate instead. Effective, sure, but it leaches toxic chemicals into the soil and becomes hazardous waste after demolition. The medieval guys used fish oil and cow dung. We use poison. But preservation only works if the building design cooperates. Here is something that took me way too long to understand. Medieval buildings were not just built well. They were designed to let wood do what wood naturally does. Breathe. See, those builders left deliberate air gaps behind wall timbers. Not because they were lazy, but because they knew trapped moisture kills wood faster than direct rain ever could. A beam that gets wet and then dries again? Fine. A beam that stays slightly damp for years? Rotten to mush. And those huge roof overhangs you see on old structures were not decorative. They extended 3 feet or more specifically to keep rain splash away from foundation timbers. Water bouncing up from the ground was the enemy, and they built armor against it. Then there is the stone plinth trick. Ground floor beams sat on raised stone platforms. Sometimes there was only a 4-inch gap between wood and damp earth. 4 inches. That tiny space saved entire buildings for centuries. But here is where it gets clever. Window and door placement was not random either. They created cross-ventilation that continuously moved air past the structural timbers. Constant airflow meant no condensation buildup. No condensation meant no rot. Now compare that to modern construction. We wrap our walls in plastic vapor barriers thinking we are protecting the wood. Instead, we suffocate it. We create exactly the stagnant, humid environment that destroys timber fastest. A 2019 study looked at failing modern homes. 68% of structural wood damage occurred in walls where moisture got trapped by plastic sheeting. We literally engineered the problem. Medieval builders designed drainage and airflow into every structure. We designed moisture traps and call it progress. But breathing wood was only half their strategy. The other half involved eliminating something we now put 20,000 of in every house. This is where medieval builders really show off. And honestly, it is the part that makes modern construction look a little embarrassing. Iron nails rust. Everyone knows that. But what most people do not think about is this. When iron rusts, it expands. That expansion splits the wood around it, and every nail hole becomes a tiny funnel, channeling water straight into the timber's core. Medieval builders looked at metal fasteners and basically said, "No thanks." Instead, they used wooden pegs called tree nails. And here is the clever part. They made those pegs from wood that was drier than the beams they joined. So when humidity rose, the pegs absorbed moisture and swelled. The joint got tighter over time, not looser. Try that with a nail. Then there were scarf joints. These connected timbers end to end using interlocking wedge shapes. The brilliant thing was that they tightened under load. The heavier the roof, the stronger the connection. It was like the building was designed to hug itself together. I have seen dovetail joints in 400-year-old furniture that still work perfectly. Meanwhile, my bookshelf from 2015, screwed together, already wobbles like a nervous chihuahua. But the real magic showed up in how medieval timber frames behaved during earthquakes. They used no glue at all. None. And yet they survived centuries of seismic activity. Why? Because the joints flexed slightly. They absorbed energy instead of fighting it. The building bent, then straightened back up. Modern rigid connections crack. Here is a number that should bother you. The average American house contains roughly 20,000 nails, 20,000 potential rust points, 20,000 moisture paths, 20,000 tiny time bombs. But removing metal was only half the battle. Medieval builders also understood something about wood itself that we have completely ignored: the difference between its heart and its skin. Here is where medieval builders would look at a modern lumber yard and just shake their heads. We treat wood like it is one uniform material. They knew better. A single tree trunk contains two completely different kinds of wood, and mixing them up was considered amateur hour. The dark center of a tree is heartwood. The pale outer rings are sapwood. Same tree, completely different performance. Heartwood is where the tree spent decades depositing its chemical defenses: tannins, oils, resins, all the things that make insects go, nope, and fungi pack their bags. Sapwood has none of that. It is basically raw, unprotected plant tissue waiting to become somebody's lunch. Medieval builders cut off every bit of sapwood before using a timber structurally. Every single bit. Even though that meant throwing away 30 to 40% of each log. That sounds wasteful, until you realize that oak heartwood resists decay 5 times better than sapwood from the exact same tree. Same species, same forest, same day of felling. A 5-fold difference. And the strange part is that sapwood actually invites problems. It absorbs moisture faster, swells more, and contains exactly the nutrients wood-boring beetles need to reproduce. It is basically rolling out the welcome mat for everything that destroys wood. I learned this the hard way with my first deck project. I bought lumber that looked beautiful. 3 years later, one edge of half my boards had turned to mush while the rest stayed perfect. Guess which part was sapwood? Modern sawmills do not care about any of this. They cut logs to maximize board footage. Heartwood, sapwood, whatever fits. Mix it all together. But medieval builders were not just picky about which part of the tree they used. They were obsessive about who actually did the work. Here is where everything comes together. And honestly, it is the part that makes me a little sad about modern building. Medieval craftsmen personally guaranteed their work for at least 40 years. If your beam cracked or your joint failed, you did not just lose the job, you lost everything. Your reputation, your guild membership, sometimes your entire livelihood. That is not a warranty card you throw in a drawer. That is skin in the game. So they built accordingly. Guild systems enforce this across generations. A master in London used the same techniques as a master in York. Same joint cuts, same wood selection, same standards. Your apprentice learned exactly what you learned, and his apprentice after him. Quality was not a marketing term, it was survival. But here is what really gets me. A cathedral carpenter knew his grandson might someday repair his joints. Think about that. He carved assembly marks into his timbers that are still readable 600 years later. Still useful, still guiding repairs today. That is not ego. That is responsibility. They also oversized everything by 30 to 50% beyond what the calculations said they needed. Why? Because they could not predict earthquakes, wars, or the possibility that future generations might hang heavier chandeliers. So they built in reserves just in case. Modern building codes establish minimum standards for 30 to 50 years of structural life. Minimum. We are literally designing buildings to be disposable. The average American home needs major structural repairs within 25 years. Meanwhile, medieval timber frames routinely outlive the civilizations that built them. Greenstead Church has stood since 1060. That is older than the English language itself. We did not just forget how to build with wood. We forgot why it mattered to build things that last.